Hi everybody, welcome to the self-check section 12.2, 12.4 video. Let's look at number one. So number one states, Amelia plays basketball for her high school. She wants to improve to play at the college level. She notices that the number of points she scores in a game goes up in response to the number of hours she practices her shot each week. And here's the following data in a table. How many hours she practicing her jump shot, and then the points per game following that practice. So we want to use a 0.5 significance level. Remember that's our alpha. To test the claim that there is a linear correlation between the number of hours she practices her jump shot each week and the number of points she scores in a game. Okay, so let's go ahead and test this linear correlation. First thing you want to do is enter in your list one and list two. So hours practicing is list one, points is list two. So let's go to our calculator and enter in those lists. So here we have the calculator. Let's go to stats, edit, and enter in a list. So make sure you're clearing out any other list you have. So 5, 7, 9, 10, 11, and 12. Now let's do list two. 15, 22 points, 28 points, 31, 33, and 36. Okay. Well, now we put our data in the list. So let's go back to the notes and write out our hypothesis and our calculator work. So our hypothesis, it's always going to be the same. We have our null, we have our alternative, and this is going to be rho is equal to 0, and rho is not equal to 0. And rho equal to 0, our null hypothesis, that means there is no linear correlation. And our alternative hypothesis, rho is not equal to 0, means there is linear correlation. Okay, and remember, we're testing to see if there is linear correlation. So this is always going to be our claim. Okay, so that's our hypothesis. Let's move on to the calculator work. Our calculator work is always the same as well. So linear regression t-test, it's always list one, list two, frequency is one, and we're choosing not equal to. Okay, these are always going to be the same. So let's go back to our calculator and obtain our test statistic, p-value, and coefficient R. Okay, so let's go to stats, go to tests, scroll all the way down to F, and we're in the linear regression t-test. So list one, list two, not equal to option, leave reg EQ blank, and hit calculate. Okay, so here's what we get. We get a test statistic T of 28.57, a p-value of 0.00008, so basically 0, and R is 0.9975. Okay, so let's go ahead and write all this down. So test statistic was T equals 28.57. The p-value was basically 0. I'm just going to write 0. And R was 0.9976. Okay, so let's go ahead and conclude our null hypothesis. So method one, remember method one is always the p-value, and we're comparing it to alpha. So our p-value was basically 0. Our alpha given to us was 0.05, and obviously our alpha is bigger. So that means we reject the null. And when we reject the null, that means there is linear correlation. Okay, so that's method one. Let's see if method two is saying the same thing, that there is a correlation. So method two, what we need to do is first thing, find the critical value. Okay, so we need a couple of things first. We need a sample size n, and we need alpha. We already know alpha is 0.05, but our sample size, we need to get how many data points there are. So in this question, we have 1, 2, 3, 4, 5, 6. 6 data points, so that means n equals 6. So let me write, for the sake of it, n equals 6. Okay, so let me come back down here and write n equals 6. So all this together gives us a critical value of what? Well, we need to go to the table and figure out what that value might be. So if we scroll all the way down to our table at the end of this packet, we see that here is n equals 6, and we have a significance of 0.05. So that means that we are here. So 8.11, or excuse me, 0.811. So that is our critical value. So let's go back up and use this value for our hypothesis test. So critical value was 0.811. Okay, so now the second step to do is compare the critical value and the absolute value of R. Okay, so R, if you recall, is 0.9976. Okay, so we need to take the absolute value of that. So absolute value of 0.9976, and we're going to compare that to our critical value, 0.811. And which one is bigger? Well, clearly the absolute value of R is bigger. So when that's the case, that means there, or we could say reject the null, and there is linear correlation. Okay, so in both method one and method two, we see that there's linear correlation from the hours practicing and points scored. So let's go ahead and write a final conclusion. So pause the video and see if you can come up with a conclusion. Okay, welcome back. So since we reject the null and we see that there's linear correlation, what we need to say is there is sufficient evidence to support the claim that there is a linear correlation between the number of hours she practices her jump shot each week and the number of points she scores in a game. So that's it for this problem. Thank you for watching. I'll see you next time. Goodbye.